So we are learning about representing decimals. And when we learned about whole numbers, we learned how to do the written form, the standard form, the expanded form, and the expanded notation. So we are going to learn the same thing with decimals, only we're going to add a little bit to that by showing the models. Models were learned in the past with whole numbers. We're going to learn models in decimals. So to begin this, we have to think about the base 10 model of a decimal. So if we have the number 2 3/4, this is 2 whole. So we could use a hundreds block. 100 cubes is equal to 1 whole if all 100 cubes are shaded. So for simplicity, I'll just draw the square. So my whole number is represented by the 2 whole 100 out of 100 blocks if this was a base 10 model. That number is 2, so I have drawn 2 models of the 100 base 10 block. In our decimal, when we say this number, the decimal is said represents and. The first digit after the decimal is a 3. That place value on a place value chart is tenths. The second digit after the decimal is hundredths. So we say the number with this THS ending. Here is our decimal, and we begin our ones. And of course, as the numbers get larger, we have our tens and we have our hundreds. Okay, so for those students just learning this, I always recommend a place value chart. We have practiced quite a bit with those this year. And my number is 2 3/4. So it would fall into 2 ones, 3 tenths, and 4 hundredths. So to model that, I have the 2 hundredths base 10 blocks that we're using, again, representing 100 out of 100 shaded cubes. Then we have our base 10 block. For some students, they will want to see it in a semi-3D fashion with the 10 cubes lined up. In whole numbers, this represents tens. In decimals, this represents tenths. Okay? Because if this tens block was in this cube, then we would have 10 of them shaded out of 100. 10 out of 100 is 1/10. For the hundredths, we have 3 tenths, so we are going to complete that model with 3 of our tenths representations. Okay? For hundredths, we are basically taking out 4 out of 100 of these little tiny cubes. So we would represent it with 4 little cubes. Okay? So this is how we would model 2 3/4 using our base 10 blocks. That is definitely a concept difficult to unwire the brain because they're still wanting to see these base 10 blocks as whole numbers. We could also just simplify it with 2 whole being represented by the squares, 3 tenths being represented by 3 straight lines, and 4 hundredths being represented by 4 small dots. That will be a student's preference, how they draw that out, as long as it's clear that these are wholes, these are tenths, these are hundredths. Now, if we were to represent 2 3/4 with dollar bills and coins, we would just throw in a dollar sign. We could draw 2 $1 bills. this would be 3 dimes for simplicity. So dimes being your tenths. And this could be 4 pennies. As decimals, this looks like 2.0 plus 0.3, 3 tenths, plus 0.04, 4 hundredths. So this is how we would represent our decimals in money. Now again, I did come back to this number here, and we said that the decimal represents and. So if I'm writing the word form of this number, it is 2 and 34 hundredths. So that is how I would write the word form. 2 and 34 hundredths. Again, big difference here. We're not talking about hundreds. We're talking about hundredths with a THS on the end. So we now have a model version in base 10 blocks. We have a model in dollars and coins. We have a word form. We have a standard form. The standard form is how we write the number every single day. The word form is how that number is read and written in words. And then you have the expanded form, which I have represented here. And then you have, and this one gets very complicated for students, especially when they're first really diving into decimals and using decimals. Expanded form is complicated because of these decimals. They see the number 0.3 and they want to forget that decimal. Or they see, okay, I have 4 pennies. Instead of thinking about it like money, they want to just put a decimal and a 4. Well, that changes the value to 4 dimes instead of 4 pennies. So I try to get them to visualize their decimals as money, and that's how we started learning about decimals this year, was we started using money to understand them. The expanded notation is something that really bogs the child's mind, but we're really just going straight off of the place value chart. So in expanded notation, we are taking it one step further than the expanded form took it. So I have 2 ones. So I am going to take this base 10 number, 1, times the 2 that I have. Okay. I'm going to add that to my decimal. I have tenths here, which is represented as 0.1 or 0.1 times 3, because I have 3 in the tenths position. Then I'm going to come in and I'm going to add my hundredths. My hundredths are represented by 0.01, and I have 4 of them. So the expanded notation of this number is 1 times 2, 1 times 2, plus my tenths times 3, my tenths times 3, plus my hundredths times 4, because I have 4 in the hundredths place. So these are the many different ways the students will be learning this week to represent their decimal numbers. And we will use that later in the week to do a comparison. We have been working on comparing and ordering whole numbers and comparing and ordering decimals. So we want them to get a visual. The other option would be a number line. We did work on those this week. So this number is 2 and 34 hundredths. So I would start my number line with 2. I would end my number line with 3. The segments in between are going to be tenths. and or hundredths. So we would start, I always start in the middle so I don't have too many lines. So this is representing 2.5. This would be 2.1, 2.2, 2.3, 2.4, 2.6, 2.7, 2.8, and 2.9. So if we drew this number line, again, this is kind of small on the screen, but these are decimals. This is 2 point nothing because we don't have to have a 0 after a whole number. So just 2. 2.1 could also be written as 2.10. We just changed that number from tenths to hundredths without really changing the value, just the appearance of the number. Because if I have a dime, I can write it as 0.1 or I can write it as 0.10. It's still 10 cents either way. We do get specific when we're trying to show them a fraction or a model of tenths or hundredths, but on this number line, they have to understand that they can be correlated similarly. For example, this number is 2 34 hundredths. If they don't understand that this is also 2.30 and this is also 2.40, it will get quite confusing when they have to plot a point on a number line that is 2 34 hundredths, which is between those two numbers. So when we ask the child to plot the number on the number line, we're just simply telling them to find where it would be located on the number line, put a point on that number line to represent it, and then label it as the decimal that they are working with. So this is an easy way to do it. Just make the whole numbers that go in the front and the back of this segment, and then do your tenths from 1 to 9 and find your middle ground. Hope this helps everyone at home for all the different models and versions. And again, we can use the number line to compare these numbers. We can use the expanded notation to compare numbers. We can use the dollar form or a regular model to compare numbers. Another thing that students see and have been working on is when they have two numbers, for example, 2.3 being compared to 2.03, we're automatically wanting to say that this is a larger number, or actually most students go for this one because there's more digits in that number. So another thing that we can do is you can put that on a number line to compare it, or we can stack it. So I can take 2 3/10 and stack it on top of 2 3/100. I can see that I have 2 digits in the top, 3 digits in the bottom, and I want to have the same number of digits behind that decimal to be able to compare. So I can add a 0. I can then say, well, this one's the larger number of the 2 digits behind the decimal, so I am going to choose this one. We don't ever point to the greater number. We always point to the lesser number. So in comparing these two decimals, 2.3 is greater than 2.03. And if we change those numbers to something a little bit different, like 2.3 being compared to 2.30, this gets the kiddos quite a bit too. Again, we want to stack those two numbers so that we have the same number of digits behind the decimal. If they add a 0, they can clearly see that these two numbers are equal. This is not greater because it has a 30 on it versus a 3. This is 3/10, this is 30/100. But if you look at the two numbers compared to each other with the same number of decimal places, they are equal.